All right, so, all right, let's check the true false. 1 is false, 2 is false, 3 is true, 4 is false, 5 is true, it's underneath my staple, 5 is true, and 6 is false. So let's go back through all the false statements. You should be able to tell me why those are false. So let's start with number 1. Why is number 1 a false statement? Nick? That is correct. It's the maximum static friction force is the force that you exert to start two surfaces sliding. Not just any old static friction force, it's only the maximum that you have to exert to get it to move. Number 2, why is that a false statement? Okay. So read what you would want it to say.
So it takes more force to start a surf or start a pair of objects sliding across each other than to keep them.
Yes, or you could just change the word more to less. Either way. Okay, so basically what it was doing was asking you to compare the maximum static friction force to the kinetic friction force. Kinetic friction is almost always less. So once you get something to move, you don't have to push as hard to keep it going. Okay, 3 was true. Can you tell me, by the way, what limiting value is being referred to in question 3? What's the limiting value that they are referring to in question 3? What's that called? The limiting value? Terminal speed or terminal velocity. Either way. Good. Number 4. Why is number 4 a false statement? Ruben, what do you think? I'm sorry? Nope. It is not inversely related to the normal force. Matt? So what do we call that relationship? We would say it is what of the normal force? Independent of, that's right. Coefficients of kinetic friction are not determined by how much you press two surfaces together. That is why when we look at page, what was it, 120? When we look at this chart, does it say that any of these values are dependent on a normal force? What are they dependent on? Only the surfaces in contact. That's it. It doesn't matter how hard you press them together. That's the normal force. You are not going to change the coefficient of friction. That's only dependent on the materials in contact. All right, question 5 we said was true. Number 6. Why is number 6 a false statement? Olivia? Maximum again. It needs that the magnitude of the maximum static frictional force is directly proportional to the magnitude of the normal force. Because remember, the static friction force is a variable amount. It goes from 0 up to that maximum. So it's only the maximum that depends. Okay, question number 1. Why do we bank curved roads? We talked about this in the presentation yesterday. It's also in the textbook. Nick?
Reduces the error, eliminates the amount of friction.
That's right. That's exactly right. We bank curved roads to minimize the dependency on a friction force to navigate the turn. That's right. Number 2, do the coefficients of either static or kinetic friction ever exceed the number 1? Ruben? Yeah, they certainly can. And I think if we look in the text, There is one right there. Copper on cast iron has a coefficient that exceeds 1. It's just a ratio of two forces. It is possible to exceed 1, and there is one right there. Copper on cast iron, shown right to you on page 120 at 1.1. So there we go. Okay, number 3. When you are standing still and then you start walking, what outside force acts upon you to cause your acceleration? In other words, what pushes you forward to make you accelerate forward? It's a static friction force, that's right, of the floor on your feet. The floor pushes you forward and up. It comes from the reaction to you pushing down on the floor. You push down and back on the floor, so the floor pushes up and you forward at the same time. And it needs to be static. It can't be kinetic, because if it's kinetic, are you going to move? No, what's going to happen? Your foot's just going to slip on the floor. You're not going to grip it to push forward. So it's a static friction force. Number 4, when a car travels around an unbanked curve, friction between the tires and the road provides the needed centripetal force. Is that friction kinetic or static? This was right out of yesterday's presentation as well. What type of friction is that, Ruben? Yeah, it's static. That's right. It's got to be static if you are not skidding. If you happen to be in a skid, you're not going to have control of the turn. That would be kinetic. All right, number 5, you're driving a car that has rear wheel drive. You know what that means? It means the rear wheels are what's helping you pick your direction. So when you turn the wheel, it navigates the front wheels, but it's the rear wheels which are pushing you forward, not the front. Most cars today, when you buy them, have front wheel drive or all wheel drive, which each wheel is then controlled separately. On an icy road, the car starts to skid off the road, so you turn the front wheels toward the direction of the skid. Why would you do that? And that's actually what they tell you when you take defensive driving. They're going to talk to you about when you get into a skid, your tires are no longer gripping the road surface. You want to put your tires in the direction of the skid. Why? Even that may sound counterintuitive. Maddie? Yes, that's part of it. And the other reason is if your wheels are pointing in the direction your car starts skidding in. So let's say your car goes into a skid and on the right side you have an embankment. You don't want to go there, but your car skids in that direction. You have to put your wheels in the direction of that skid until the wheels start to get the grip back. Once you're going to feel it. If this ever happens to you in the winter and you get into that skid and you're trying to go this way with your wheels, going away from that embankment, even though your car's headed that way, you're not going to get your wheels to then re-grip the road. You have to put them in the same direction your car is moving in order to reestablish the static friction, the grip. Once you feel that grip, boom, then you move it out. That's what experienced drivers do. And I know a lot of you don't have practice doing that. The best thing you can do as a young, inexperienced driver in the winter is go to an empty parking lot that has not been plowed and get your car to go into a skid. And then practice getting it back out. That is how you will avoid an accident. And God, you guys at your age, you get into an accident, depending on how close that accident is to when you got your license, you could have your license revoked, or your insurance rates will probably triple or quadruple what they currently are. And you're probably already paying a ton for your car insurance. If you don't know how much you're paying for your car insurance, I can tell you it's probably triple what I'm paying for mine, because I'm old and I got a lot of experience driving. I started driving when I was 16 and I'm 51. So I've got a lot of experience driving and I've never had an accident. Okay, so thank goodness. Knock on wood. I don't want to have an accident later today. Okay. All right. Number 6. Certain racing cars have an airfoil over the top of the car. Some of our school buses have this as well. The airfoil deflects air upward. What advantage is gained by deflecting the air upward when the car turns a corner? Why do we put airfoils on cars? We do them on race cars all the time. We have them on some school buses. Some of your regular vehicles have an airfoil on them as well. Why would you want to have one? Think about forces. It's telling you something about forces in this question. Addie? Yeah, because if the airfoil is pushing the air up, then the air is pushing the airfoil down, which increases the normal force pushing down into the ground. If you have more normal force, what's that going to do? Increase the amount of frictional force. If you have more friction, it makes it easier to turn the car. That's what enables you to turn. Without that friction, you're not making the turn. Your car's just going to slide across the road surface. So that's the advantage of doing that. Why would we put those on school buses? It's a safety measure. So that way in the winter time, in particular, a school bus can avoid an accident on a slippery road surface and still make the turn, especially because our school buses have a much higher center of gravity. So as they turn, they have a propensity to flip. We don't want to do that with precious cargo on the school bus. Okay, so they'll put these airfoils on the top to increase the normal force, which increases the amount of friction without having to have salt, sand, that kind of thing on the road surface. Just makes it a lot easier. Okay, any questions? All right, so your homework for tomorrow is the first written assignment at the end of the chapter. Assignment 23. It's questions 34, 35, 37, 38, and 42. There's 5 problems for tomorrow that you want to get completed. Again, that's 34, 35, 37, 38, and 42. Again, I'll say that one more time before I take it off the screen. That's questions 34, 35, 37, 38, and 42. There are 5 of them due tomorrow at the end of chapter 5. Now, I'm asking you to read Lab 7 Part 1 for tomorrow. There's a lab handout posted in Google Classroom this morning for Lab 7. Just read it through, because after we go through these 5 questions tomorrow, we're going to talk about what you need to do for Part 1 of Lab 7. I did not give you a lab procedure for Lab 7. You and your group are going to have to write a lab procedure and get it approved from me before I will let you conduct the lab. All right, so this will be an exercise in can you write a lab procedure to collect the data you need. But read it over. Make sure you truly understand what I'm asking you to do, because there are multiple ways that you can do the lab. And you will be evaluated first on how well your lab procedure, if it meets the criteria. If it doesn't, you're losing points. And I will just send it back to you and say, nope, no good. You can't do the lab. And every time I have to send it back to you, you lose a point on the lab. Right? So the only way you're going to get 100 on this lab is if you get it right the first time. So we will talk about that tomorrow after. And then Friday's class is an entire class where I'm giving you the opportunity to work on writing that lab procedure. Okay. You will see also posted in Google Classroom that I discussed the other 2 parts of this lab. Part 1 is the procedure. Part 2 is collecting the data and evaluating somebody else's lab. So you are not going to conduct this lab. You're going to write it up, and then that procedure is going to another group to collect all your data, to follow your steps. We'll see how well they can do it. And they're going to evaluate your procedure to give you 5 points and give you your data. And then the last part of the lab is analyzing it and writing up a brief report of the analysis. It's not a full lab report. And that's 5 points as well. Okay, questions? All right, so make sure you read that for tomorrow as well. All right, so I'll let you do your thing. If you have questions,